So last time we were talking about the surface area of revolution. So this is the formula we're going to derive. So basically, if we take a line that looks like this, so here's my line, and I revolve this line around the x-axis, then this point will revolve all the way down here. That's not a good revolution. This point will revolve all the way down here and come back around. I'm having trouble today. I'll erase that E, get rid of it. Thank you. Let's try this one last time. Okay, and so when it does that, this piece right here is simply just, again, the length. And then this piece right here simply just is this length, which is the circumference of that circle. Okay, so that length just becomes the circumference of the circle. So it's 2 pi, whatever this radius is. All right, well, that radius is just the height of the function. So that's just y of x. So when I go to find the surface area, that is, if I were to try to cover this thing with aluminum foil, this area would just be a rectangle. So I would get 2 pi r, that's the first piece, times L. Why is this doing this? It's not supposed to do this. Where's my do not? It's not, I don't even see it. I'm sorry, guys. Something is just, stuff is coming through on my iPad and it shouldn't be. I have it set for do not disturb. There it is. Okay, now it's back. Okay, that's crazy. Okay, let me go back to what I was teaching because that messed me up. Courses. Okay, so we were here. So I said, now suppose we have this region instead. Okay, so if this region, we have this, and we're going to take again and still revolve this line. And we're going to revolve that whole line just like this. Hold on one second. So when we revolve this thing around the x-axis, notice now we get a different radius over here. So the radius over here is completely different than the radius over here. So the radius is always based on the height, and the height is this function y. Okay, so that's what the radius of the cylinder of this, whatever we're looking at, is always based on. So for any x, the height is always y. So the radius of the circle that occurs at x is just y. But what do we do about that length? Well, we already figured out from before that that length was the square root. So we said it was the square root of 1 plus dy dx squared if you multiply by the dx. So now I'm going to take and do the same thing. I'm going to put this L in there. So now my surface area of revolution becomes a different curve. So now I get this. So I get this curve. So here I have 2 pi r. Well, I know r of x is now going to be y. And instead of the height, I'm going to have the length. And that's going to be the square root. If I can get this thing to work today. Thank you. The square root of 1 plus dy dx squared there we go. Yeah, that's what, oh, that's what I want, but it disappeared. Dx. Okay, so that is my formula for surface area of revolution. Okay, so now what do I do with that? Well, this is actually just find the problems. So now we have two things. So this is the surface area of revolution for a line y equal f of x rotated about the x-axis. All right, so we get this formula. Ooh, I got two x's. So now we can talk about the surface area of revolution for the line x equals g of y. Now, I know you guys don't like x equals g of y, but it happens. Rotate it about the y-axis. And what is that going to look like? That's going to look pretty much the same. All right, we're going to have s is going to equal the integral from a to b. So we're still going to have that same integral. But now we're on the going from y, so we're going to do c to d. So we always use c and d. And then this is going to be 2 times pi. And then now I'm going to have x of y. And get this dx out of there. That doesn't belong there either. Thank you. All right, then I'm going to get the square root just like before. But this time now I'm going to have of 1 plus, and this time I'm going to have dx dy. That whole thing gets squared. And then dy. Okay, so let's do some of these. All right, so now we know the surface area of revolution for a line y equals f of x. So I have some line, whatever it looks like, I rotate it, okay, and it gives me a surface. I want to find the area of the surface. I have some curve like this, and I rotate it. I want to find the area of the surface. So the only way to do this is to just do it. All right, so let's grab a problem. And here we go. Now, I did this for the other class, and they seem to be I had a large contingency of students that were unclear. So we're going to do this problem, and then I'm going to do the same thing with you that I did with them. Okay, so find the area of the surface generated by revolving the curve y equals 2 square root of x on the interval 1, 2 about the x-axis. So just for the purposes of understanding what we're doing, I'll draw the picture, but it's not necessary to draw the picture. I'm going to draw the picture just for you guys. Okay, so y equal to the square root of x looks like this. They said between 1 and 2. So here's 1, here's 2. So I only want this portion of the curve. So we're going to get rid of this piece because I don't need it. And I'm going to get rid of this piece because I don't need it. So that's the only portion of the curve that gets rotated. So when I rotate that, that's going to give me something down at the bottom. So let's see, 1, 2, 3, 4. So when I rotate that, I get something like that. And then I'm going to rotate the other side. And so as you can see, here's the line that was rotated. Whoa, no. Don't want you to do ink the shape on that one. Yep, I just want my own line. Okay, so the line is right there. Okay, so as you can see, here's the surface on the outside. So this is the surface. And it's hollow. Remember, we are doing surface area. So what's on the inside is nothing. All right, we're only concerned about the metal that makes the horn, or the metal that's going to make the urn, or whatever it is. That's all we're concerned about. I don't know if it was y'all class or whatever that I said. I can't stand coloring. Okay. All right, there we go. All right, so that's the surface. Okay. And we need to find the surface area of it. Okay, so again, what were our steps? Write down y, find y prime, square the derivative, add 1 to it, simplify it, stick it under a square root, and then put it in the integral. Same thing. Okay, so y is 2 times the square root of x, which I'm going to conveniently write as 2x to the 1/2 power. Next step, find dy dx. That says take the derivative of that. The 2 is going to come down and hit that, and I get x to the negative 1/2. Now I need to square it. Okay, dy dx squared. That's simply x to the negative 1. Okay, we're smoking here. That's good. Add 1 to it. So 1 plus dy dx squared is 1 plus 1 over x. And I need to simplify that. So I'm going to make it x plus 1 over x. There we go. Nice and smooth. Okay, now the last step is to put it inside the square root. All right, so here's the square root of 1 plus x plus 1. Oh, we already did that. We already added 1. I apologize. The only thing inside this square root is x plus 1 over x. So far, all I did was the basic steps. No integration, nothing difficult. I took y, I found its derivative, I squared it, I added 1 to it and simplified it. Okay, just like back here. Okay, I found y, I differentiated, I computed y squared, I added 1 to it, I simplified it, Now I'm going to put it inside the square root because it's simplified. Okay. There we go. So let me just, now I know why I was writing the 1. I know why. I was writing the square root of 1 plus dy dx squared is equal to the square root of x plus 1 over x, because that's what we get. Okay, so any questions so far? Y'all know where we are, what we're doing? Okay. So we get S is equal to, let me grab this formula. I should have put that in parentheses. I didn't, but that's okay. I'll put it in the parentheses down here. Okay, I have a question. Okay, thank you. All right, so this actually, I didn't do it, but I should have. This is the whole dy dx squared, the whole thing squared. Okay. All righty. So S is equal to the integral. They told us from 1 to 2. They already told us that in the problem, 1 to 2. I need 2 pi. Y. Okay, y of x was 2, the square root of x. And then the square root of that becomes the square root of x plus 1 divided by x dx. Well, that's fantastic, because I can use algebra on this and get 2 pi. Oh, I'm going to make it 4 pi. Let's just get that going already. 4 pi, the square root of x. And this term right here, we can use properties of square roots. And this just becomes the square root of x plus 1 over the square root of x, just using algebra. Dx. Now that's beautiful because these divide out. Wow, how nice is that? So this is now the integral from 1 to 2 of 4 pi. And then this just becomes the square root of x plus 1 dx. Okay, so now this is simple. This is, you can use substitution. You get u is equal to x plus 1, du is dx. When x equals 1, u equals 2. And when x equals 2, u equals 3. Okay, so that's the whole substitution right there. So I get S is equal to the integral 1 goes to 2, 2 goes to 3, 4 pi u to the 1/2 power du. So I can pull the 4 pi out. Then u to the 1/2 becomes u to the 3/2. Divide by that, you get 2/3. Evaluate it between 2 and 3. So I get 8 pi over 3. And then I'm going to get 3 to the 3/2 power minus 2 to the 3/2 power. And that's the end of my problem. Okay, any questions? Okay. Okay, so this next problem is a little bit different. So the problems on the test, or just in general in life, you will see problems, and some of them are not, it is not easy to integrate. So if I already know that the problem is going to be impossible to integrate because one, either you haven't been taught that skill yet, or two, it's just not an integral that anybody can solve. It will say set up, but do not integrate. Okay, so when it says set up but do not integrate, I expect you to get all the way to the end of the integral, but when you get there, I want you to quit. So what I'm going to have you do is set this one up, get all the way to the end, and stop right there. So I'm going to go ahead and take roll. Okay, so here's the question. Everybody must participate, because if you don't, then that lets me know that you have walked away from your computer and you're just logged in doing something else, who knows what. Okay, so I am going to look to see who's really here, and this is going to give me an idea of what's going on. So you must type into, I have 17, I have 18 people that say they're here. 17 people that say they're here. We'll see. I need you to type into the chat one of two words, clear or unclear. Clear or unclear. If you don't want it to go to everybody, then just send it to me. Okay, nothing's happening in the chat. Clear or unclear. Good. I'm up to 3 people. 4. Good. Keep coming. You can send it to me if you don't want anybody else to know. 7, 9, 11, 12. Good. 13. I'm missing 4 people. Missing 3 people. Clear or unclear? I'm actually going to go back and look at this chat today and see who put in, 15. I'm missing 2 people. All right, I'm missing 1 lonely person. Okay, let me look in the chat. Out the 16, we got them all. Okay, so let's look in the chat. Okay, so I have, starting with this class. Okay, 1 unclear, 2, 3, 4.
Hey, Dr. Lack, I'm just only unclear on the sketching part.
On the sketching?
Yeah, sometimes
Okay.
I might get a little bit wrong.
All right, well, I'm going to eliminate that on the test. I decided I'm going to give you the pictures because I don't want you guys hung up on the pictures because that's crazy. Okay, I'm not even going to draw this one. Not even going to draw it. One of y'all is going to help me do this. Help me set this up. Do the steps. What's the first step? Identify why. All right, who's going to talk me through this one?
I get a shot.
Okay, so y is equal to x squared. What do you do next?
Write down the equation that we're going to use with it.
Okay, so that's okay if you want to write the equation. Just so I have the equation near me. Where is it? Oh, that is not the equation. Control Z. Let's go back and find the equation. So this is the equation we're going to use Okay, so I explained this to the other class, just like this is baking a batch of chocolate chip cookies. All you need to do is find the things that are necessary in the equation, make them match up, and you are done. This is not a hard topic because all you have to do is stick in A, B, Y, and dy dx squared. Okay, Johnny, keep going.
And you get the derivative, the dy,
Yes.
you got dy dx equals x squared.
Okay, so dy dx is x squared. So all right, we're getting there. Dy dx is equal to x squared. Okay, what do I do next?
No, would that just be 2x?
Oh, I'm sorry. I'm writing x squared. I meant to write 2x. I'm like, that's not going to work. Okay, 2x. Go ahead.
Now after that, then you I guess you write the equation now that we're using.
Nope. What does this say? That says dy dx squared.
Oh, then we square it.
Find that. And then it says I need 1 plus that. Okay, can I simplify that anymore? 1 plus 4x squared. Can I simplify it?
No.
No. So I'm going to take this and I'm going to plop it right inside of this integral along with everything else. So now I get S is equal to the integral from A to B. They wanted me to be on the interval 0, 2. Two pi y x squared, the square root of 1 plus dy dx squared. Well, that's 1 plus 4x squared. And then the only thing left is to do dx. And put a period there because it says set up but do not integrate, and I'm done. None of this was hard. None of it. I took the y they gave me, I found its derivative, I squared it, I added 1, and I put it underneath the square root. Normally I would simplify, but I don't have anything to simplify. It's 1 plus 4x squared. That's the end of that problem. If I had a Saturday session to
I have a
just
question.
go ahead.
So if we leave it in that form, do we still get like all credit? Like I know because
If this
sometimes
one-
when you enter,
This one says set up, but do not integrate.
okay.
So that's a full credit problem right there.
But when we do integrate, are we able to leave it as like let's say we
this.
would integrate the numbers in and do it like this minus this? Could we leave the problem as that, or we have to break it down even more?
You see, I did here. I plugged in 3, so it gave me 3 to the 3 halves, and I plugged in 2, it gave me 2 to the 3 halves. I can't simplify that, and I'm done. So this one was not set up, but do not integrate. I wanted the answer. I wanted the area. This one, I wanted the area, the surface area. I wanted it. I wanted the number. This one, I want you to set it up, but not integrate it. You don't know how to integrate that yet.
I'm just talking about like a normal integration problem, though. Like the ones that we had on the homework, where like it would equal like 49 pi over 5. Do we have to bring it like that, or can we bring it as like when we're plugging in numbers?
It'll be 49 pi over 5 because you won't have a calculator. So that's the answer.
Okay.
Yes, ma'am. Okay. Okay. Here's another one. Set it up, but don't integrate it. So I want everybody to start working to set this problem up. Now this one, oh, this one's a toughie one. Well, not really. This one is going around the y-axis, so it's going like this. So this one, I'm going to use the other formula. I'm going to use S is equal to the integral from C to D of 2 pi x at y times the square root of 1 plus dx dy squared dy. Yeah, I know. Okay. All right. So what is x? X is equal to y plus 2, the square root of y, I'm going to write as y to the 1/2 power. Dx dy is 1 plus y to the negative 1/2 power. Dx dy squared is 1 plus y to the negative 1/2 power squared. And we have to FOIL this. I'll try to tell you where when we FOIL. So this is going to give me 1 plus 2y to the negative 1/2 power plus y to the negative 1. Now I have to add 1 to it. 1 plus dx dy squared is 1 plus 1 plus 2y to the negative 1/2 plus y to the negative 1. So that looks like 2 plus 2y to the negative 1/2 power plus y to the negative 1. And we're going to get rid of these negative exponents and make this look, pull out 1 over y, and we're going to get 2y plus 2y to the positive 1/2 power plus 1. So that looks so much better now. Okay. So now the square root of this thing is not cute, but it is what it is. 1 plus dx dy squared is going to tell me to take the square root of this thing. So when I take the square root of it, I'm going to get the square root of 2y plus 2y to the 1/2 power plus 1, and there's the square root of y in the denominator. So now that whole thing is simplified. How wonderful. So now I can go to my integral S. It's going to be the integral from C to D. Y starts at 1 and ends at 2. 2 pi x was y to the square root of y. And then I have to multiply by this thing. dy. I'll give you a minute to catch up. You should see something simplifies, which it does. I can take the square root of y out and get s is equal to the integral from 1 to 2 of 2 pi. This is going to be the square root of y plus 2 times the square root of 2y plus 2y to the 1/2 plus 1 dy. And I'm done because it said set up but do not integrate. So I can't integrate that. Actually, that's pretty ugly to integrate. Yeah. So we'll leave it just like that. Okay, any questions? For those of you who typed in unclear, is it getting a little better?
Yes, just a crow,
Just what?
a little bit.
A little bit.
Dr. Love, what was that, the step again about the algebra part?
Okay,
There was
so
a
there,
word for it. You said, the rule for square roots or something like that.
oh, there is a rule for square roots, algebraic rule for square roots. That is, if you take the square root of a over b, it's the square root of a over the square root of b.
Okay, now I follow.
Okay. All right, any questions? All right. Let's set up this one. Now this one, you have to do all the way through. All the way through. And this one is a y is equal to x cubed over 9. And this one's about the x-axis, so I'm going to use the regular formula s. The integral from a to b of 2 pi times y times the square root of 1 plus dy dx squared dx. So I want you guys to get started working on this integral. I'm going to pause it for a minute, give y'all a chance to work on it. Let me see, I'm going, Lawrence, are you around? Lawrence,
Yes.
okay, help me out.
Okay.
Get me started. Just get me started.
Okay, so y would be x to the power of 3 over 9.
Okay,
dy dx is gonna be it's gonna be 4/9 to the 4, x to the 4.
Okay, you're integrating. You're finding the antiderivative. I need you to find the derivative. So you started here. Let me show you what you did. You started here at x cubed over 9, and you went up to the function it came from. I need you to take the derivative. So this was anti-differentiation. I know it is a lot to keep in your head. I don't know how I keep it in my head. Okay, Lawrence, do you understand?
Yes.
There's an antiderivative and there's a derivative. Okay, so Rodney typed in the chat, he's trying to help you. So he said, if you take the derivative, the 3 comes down
Okay.
and then you get x to the 3 minus 1. So you end up with x squared over 3.
Okay.
Okay, good now?
Yes.
All right, so you found the antiderivative. We only find the antiderivative when we have that integral sign. So this
Oh,
one is the sign like that. This one is the sign like this.
Okay.
This is differentiation. This one says anti-differentiation. Okay.
Okay.
All right, keep going. Now you gotta find. Now you gotta square it.
So it's gonna be x to the 4th over 9.
Okay, awesome. Now you're gonna add 1 to it. Now here's where I ask you, can you simplify that any further?
No.
No. Okay. So that means since we can't simplify this any further, we are ready to just stick it into our integral. We've gotten as far as we can go. If we could simplify it, we would, but we can't. Okay?
Okay.
All right. Let's see. Thank you for your help.
Welcome.
Let me see who else I may call on. Bianca.
Yes.
Okay. So we're going to put everything inside the integral. So S is equal to the integral. So what are A and B?
0 and 2.
0 and 2, okay. And then I have 2 pi. What do I put in for Y?
X cubed over 9.
X cubed over 9, awesome. And then what comes next? That square root?
Square root of x to the 4th over 9.
Plus the 1, don't forget
Plus
the
1.
1. Yeah. And then the only thing left to write is dx. Good. Okay, we're going to do this by use substitution. Bianca, what's U?
U is 1 plus x to the 4th over 9.
Good. You guys are getting so much better at this. Okay, so what's du?
Du would be it would be 4x cubed over 9.
And what do you have to put behind it?
du
dx.
dx.
The du is on the left side, dx is on the right. Okay. Now, in the problem, I see I have an x cubed. So if I were to write this as pull out the 2, the pi, and the 9, I have the integral from 0 to 2 of x cubed, and then I still get the square root of 1 plus x to the 4th over 9 dx. So Bianca, I see the u. This whole thing is going to be u, right?
Yes.
Okay, so this part, x cubed dx, is what I have to solve for. So what do you get when you solve for x cubed dx?
Oh, wouldn't it just be 4x cubed over 9?
Well, that's what I have. I have x cubed dx. Notice I have x cubed dx right here.
That could be 9/4 du. Not sure.
Okay, so Bianca, I'm going to multiply both sides by 9/4. So I'll get 9/4 du. Do you see that?
9/4. Yeah.
Okay. All right, so now when x is 0, what is u?
Oh,
Go ahead.
0.
We got to plug it back into here. When x is 0,
Okay.
what is u? I think you're stressing.
Yeah. Is
Okay.
it just 1?
Yes.
Okay.
That's why I said you're stressing, because it's just 1.
Yeah, I was thinking about it too much.
You think, okay. So now when x is 2, what is u? It's 1 plus,
Oh. It's, hold on. Is it 25/9?
okay, I'm taking 2 to the 4th. Okay, actually, you're right. 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 That's the final answer. This is 16/9. You are so correct. It is 25/9. That is right. Awesome. Okay. All right. So now S is equal to integral. Where I have 0, I put 1. Where I have 2, I put 25/9. Oh, I forgot my outside stuff. You put that back. 2 pi over 9. The integral from 1 to 25/9. And then can you, let's see, let me get somebody else. Who can I pick on to call? Oh, that's the wrong thing. I don't want that. I want the, thank you, Bianca.
You're welcome.
Brian. Brian.
Yep.
Okay. Let's finish this off. How do I finish this off?
Don't you plug in the values for you?
So 1 plus x to the 4th over 9, that's just u, right? So that part just gives me u to the 1/2 power because it's underneath a square root. So this is u, and it goes in here. Question?
Nope.
Okay, so what do I do with the x cubed dx?
Don't you have to bring the 4/9 out?
Okay, we already did that. So we
Okay.
found x cubed dx here.
Okay.
So what do I put over here now in my integral?
That's just du, right?
Well, it's 9/4 du. We figured out the x cubed dx is actually just 9/4.
Oh yeah, I see. You multiply it. Yeah, so it's 9/4 du.
Okay.
And then you bring that out to the, or multiply it by the 2/9 pi.
And so what do I get outside?
1/2.
Okay, so I get pi over 2. The integral from 1 to 25/9 of u to the 1/2 du. Okay, what do I do with that?
So you get u to the 3/2 times 3/2.
U
I
to
mean, divided by 3/2, which is 2/3.
2/3, and I still have the pi over 3 out here. And this gets evaluated between 1 and 25/9, right?
Yep.
Okay, keep going.
So then you replace u with 1 plus 16/9, which is 25/9.
To the 3/2 power minus 1 to the 3/2 power. So we get that. Are you happy with that?
Yeah, I would rather not do all the math, but I mean, if we have to do all the
Yes.
I got a calculator though.
Oh my God, I would rather not do all the math. And
That's
I'm
why I got a calculator.
No. No. Okay, so now this, I'll take this as an answer, but this does simplify. Okay,
I'm confused.
what's that? Where you
I'm
can,
confused on how it's 1 pi over the third. I thought it would be 2 pi third over the third.
I think she's talking about multiplying the 2/3 by the pi halves, maybe.
Yeah.
So it'd be like, so they will simplify to pi thirds because the two cancel.
wait a minute.
The twos, don't they cancel?
You'll always find my mistakes.
I thought the
stuff with the first class, they don't see a thing.
I thought the twos canceled though.
Oh, I know what's wrong. This is supposed to be a 2. That was the problem.
Oh, okay. Oh, yeah.
That was supposed to be a 2. So yes, the 2's do divide out. Thank you for catching that mistake. Okay, so now this just means this is pi over 3. This is literally the square root of 25/9 cubed minus 1. So that is pi over 3. This becomes 125/27 minus 1. And so this answer becomes 98 pi over 81. Okay, so this is what do you call it? Edgefinity would be looking for. Okay, you'd be plugging it in and Edgefinity would be telling you it was incorrect. Okay, all right, any questions about that? I hope it's a little bit more clear.